Hey, here we go. This is V41. This is the shortest video ever made. Really, it's just going to be a couple slides. I wanted to take just a moment and let you look at the most missed mastering questions from class 3 and give you a chance to look at those before we go too much further. So here they are. I'm going to show you these for just a second. I'm going to actually disappear. Hang on. There. I'm going to give you a moment. I'm going to encourage you to pause the video. Please, please, please pause the video and try to solve these 4 questions. Then I have one more, and then we will continue. So, ready? We're going to pause in 3, 2, 1. Okay. Hopefully you've unpaused and now you're back listening to this. Let's look at these 4 questions quickly, and then we have one more to consider, and this one's done. So when we said that water is molecularly sticky in question 1, and even though that sounds a little bit funny, what are we saying when saying water is molecularly sticky? Well, many of you chose that water forms lots of ions, which means water is attracted to itself. Water can ionize, but actually that's not the best answer. The best answer is D. Since all water molecules have positive and negative ends, water molecules tend to attract each other through hydrogen bonds. Why does water have positive and negative ends? Remember, oxygen is very electronegative, so it draws electrons very close to it, and because of that, oxygen is negative, a little bit negative, hydrogen's a little bit positive, and then therefore water molecules are attracted to one another. Question 2. Which of the following is not a compound? A compound's definition means that it contains more than one kind of element. So methane is CH4, carbon dioxide is CO2, and water is H2O. All of those contain two, well, in this case, just 2 elements. Oxygen gas is formed by oxygen binding to oxygen, so oxygen is not a compound that's going to be just a straight molecule. Question 3. Which type of bond is formed between the oxygen atom of one water molecule and the hydrogen atom of another water molecule? So I think some of you got confused in this one because you were trying to consider the bond between oxygen and oxygen and hydrogen here. This is an example of a polar covalent bond because the electrons are not being equally shared, but that wasn't the question. Of another water molecule. So how does water bind? Here's another water molecule here. Here's oxygen and hydrogen and another hydrogen. So the question we're being asked is to consider what is the bond we're talking about right here. That is a hydrogen bond. That is a weak attraction between hydrogen, which is a little bit positive, and some other element rather. In this case, it's going to be oxygen. Okay, and question 4, which of the following is true of atomic weight? So when you consider the choices here, atomic weight is determined by the number of electrons. No, can't be that one because electrons are not involved in atomic weight, right? Atomic weight of an element is calculated by adding the masses of protons and electrons. You know it's not electrons, but it's rather going to be neutrons. So it's not that one. Atomic weight of an element is approximately equal to the number of protons in its nucleus. No, because again, it's going to be protons and neutrons actually are going to give us the approximate atomic weight, so it can't be that one. You see we have left with a choice here. Of an element is approximately equal to the mass number of its most abundant isotope. That is correct. And remember, we had an example in class. Carbon, its atomic weight is 12.011. The reason that's true is most carbon is in this form. Most carbon is carbon 12, which means it has 6 protons and it has, it's hard to write with a mouse, sorry, and 6 neutrons. So that answer is actually the correct one. So hopefully these make sense. These were the most missed. I will show you one more question and we will then wrap up. A 65-year-old patient came to the emergency room with complaints of severe heartburn unrelieved by taking large handfuls of antacids. what would you expect the pH to be if someone is taking antacids, and why? Well, if someone's taking antacids, I'm back. Antacids are going to help neutralize acid. So somebody who took a lot of antacids, their pH is going to be what? Toward the acidic side or toward the basic side? Toward the basic side. So they're going to be going to cause the pH to be more basic. So all the choices here, the best choice is this one. The pH would be high. Antacids are basic, and too many antacids would result in a relatively alkaline, that is, basic state. Okay, review that some more if you want. If you want to go back and look at the other questions, of course you can do so. This wraps up V41. All we're doing here is looking at the most missed mastering questions from homework. On to V42.